In this video, we'll discuss the concepts of encapsulation and information hiding. So recall that encapsulation is the idea that objects can contain both state and behavior in one single entity. Information hiding, on the other hand, is a principle in object-oriented programming that says we should limit the access to the internal parts of an object from outside sources. That is to say, if an object has some data attributes, we should be preventing external things outside the object, from being able to directly access or directly change those attributes. Okay, so what we should do is make those attributes private to only the object, kind of like how local variables only exist inside of a function. The idea here is that this is going to prevent against some accidental corruption or intentional misuse of our data attributes. So for example, think if we had created a bank account class or a bank account object that had balance attributes stored inside of it. If outside of that object we had the ability to just set the value of balance, then we could just set it to billions of dollars, or if it was one of our enemies, we could set it to negative money or zero. So outside code should be limited to only using public methods that then have access to change those attributes in controlled ways. So the object then remains in control of its own state and provides an interface to the public to be able to request changes to that state, but not directly mutate that state. One of the other nice things about having this information hiding is if the internal structure of the object changes. So if we want to rename our attributes, or maybe we have 4 attributes we want to group together into a list, when we redesign our object, things accessing our object through this interface, through the methods, don't have to change how they're talking to our object, because the interface can remain the same while the internal structure of the object can change to be optimized. So it increases the lifespan of our code this way. Now, just as an aside, I want to mention the terms encapsulation and information hiding are often used interchangeably. It just comes to a fact that when we store state and behavior together, the behavior should pretty much always control access to that state. Okay. So the syntax for constructing some private attributes is to use 2 underscores here. So self dot and then underscore underscore some attribute. Okay, so instead of just being self.attribute, we put 2 underscores in front of it and then give it a value. 2 underscores tells Python to make this attribute private. Says to the code outside of this, don't use these attributes, they're hidden. Now, Python doesn't have the greatest information hiding schemes in the language. So in fact, this is more of a suggestion than an actual control. When we put 2 underscores in here, it doesn't actually hide the variable, it just secretly changes its name. It's called name mangling, so that you can't read the code and see, okay, well, that it has a name variable, I'm just going to directly access .name. When you go to actually access .name, it doesn't exist. It's called something completely different, so you can't just type in something to make it work. Once we've managed to hide our attributes by using 2 underscores, that makes these attributes now only accessible inside the object itself. So we can have methods that can access it, because inside the class we can say underscore underscore attribute still, that's no problem. But outside of the code, that attribute no longer exists. It has some hidden name. So what's normally done to provide an interface for external code to use those attributes is 2 common types of methods known as getters and setters, or more formally, accessors and mutators. So these allow for read and write operations on those private attributes, but they control allowed values and they don't expose the attributes themselves. So for example, for a bank account, I could say, I could create an accessor called getBalance that would return the number of monies, the amount of money inside this bank account, but it wouldn't return the variable itself. It wouldn't say, here's the variable, do with it what you will, please don't do anything bad. It would say, here's a number that represents what's in that variable stored somewhere else in my object. Okay, so accessors are methods that allow reading the value of these private data attributes, but without being able to access those attributes themselves. Whereas mutators are methods for altering the value of these private data attributes, but doing so with control. So if, again, for our bank account example, we could have, let's say, a withdraw method that first checks, is there enough money to do the withdraw before actually changing the balance variable to make that withdrawal occur. Okay, so it has some sort of control or some sort of if statement, some conditions to say you can do these actions, but only so long as you're using these values, or only so long as the state supplies enough money for it in this instance. Okay, so let's take a look at another example here. Let's create a dice class. So let's go back to here, create a new file, die.py. Find dice.py. Okay, so in this we're going to create a die class. It's going to be a bit of a random class because we're rolling dice. So I'm going to start by importing random. And then class die that represents one singular die, or the design of one singular die. So defines a die class that can have any number of sides. So it doesn't have to be a 6-sided die. You can have a 10-sided die or a 20-sided die for those D&D players out there. So we need an initializer. So def __ init __, and then the self attribute by default. We're also going to include a parameter for the number of sides. So num sides. So when we create a new die, we're going to say I want a 10-sided dice. We'll pass in class die, and then we'll say 10. All right. So attributes for a dice, we're going to need the current side, and we'll say by default all dice start on 1, and then a max number. So self.num sides equals this parameter num sides. Okay. So that creates our dice object, and then we also need to have a roll behavior to actually execute the purpose of these dice. So def roll and then self. And we'll say self.current side equals, and we'll just generate a random side between 1 and the number of sides of our dice. So random.randint 1, self.num sides. Okay. So this is going to mutate our dice object. It's going to change the value of current side to be some random value. All right. And that's our dice object. So let's go down to main and use this. So def main, we're going to start by making a new 6-sided dice. So make a new 6-sided die. And to do that, we'll say die equals, and then we'll call this class. So capital D-I-E, and we'll pass in the number of sides we want, so 6. So die equals die 6, and then let's roll it and report it. So die.roll. Notice that doesn't take in anything beyond self, so we don't include any attributes, arguments here. So it just rolls, and that's going to change the side, the current side of our dice. So let's now report the current side. So print, I rolled a str, and I'll say die.current side. Okay. So let's test this out, make sure everything works. This is die.py. Oh, dice.py, sorry. There we go. Helps if we call main. Try again. There we go. I rolled a 1. Roll it again. We get a 6, 5, 2. So we're getting random numbers, all within the correct range. So that seems to be working fine. So let's roll this again. Let's see what else we can do with this dice. So roll it again. So die.roll. But this time, we're going to cheat. So I'm going to say die.current side equals 10. And then we'll print out what we got. So we'll take this line here, and we'll print again. So print I rolled die.current side. Save, and run it again. So we got a 1 and a 10. We run it again. We got a 4 and a 10. And then another 4, and a 6 and a 10. So we got a 10 on a 6-sided dice. So I want you guys to go find a 6-sided dice and see if you can roll a 10 on it. If so, then this code's fine. If not, then something is definitely wrong here. So the issue here is that we can invalidate the dice roll, right? We can make it so that the integrity of this object is violated by the outside code. By saying current side equals 10, we're changing the value of this variable to something that it should never be. Current side should always be a number between 1 and the maximum number of sides, and we have the ability to change it however we want. Now, as the designers of the dice class, we should have foreseen this and made it so that that's not possible, right? We can we can make sure that we only ever use current side correctly, so it's okay for us to have that variable. But by exposing it to the public, which in this case is the main method, people outside the dice class maybe don't have the same respect for the object that we created, and they're going to just use whatever they want. So in this case, current side equals 10, and they've managed to upset what it means for this dice. So let's add some information hiding to our dice object by making this a private variable. So underscore underscore. So again, in Python, this says, I would like this variable to only be accessible inside this class. So we need to change it everywhere where it exists. So underscore underscore. And let's see what happens if we try printing that out here in the global space. First off, let's just get rid of these lines here for a quick second. I'm just going to comment all these out. I'm just going to deal with 3 lines. There we go. I'm going to deal with this first one here just to see what happens. Okay, we'll come back to the ability to cheat in a second. But what happens if I try to just report this new private variable, newly private variable? Python.dice, and it crashes. So it got to that line 19, this line here. So creating the dice, rolling the dice, still no problem. That all seems to work. But it got to line 19 and said, well, the die object has nothing called current side, right? Now inside the class, sure enough it does. This was not an error. But outside the class, if we try to access the current side from dot notation saying die.current side, it no longer works. It doesn't make sense to Python because it's now a private variable. So we can't access private variables from outside of the class. Obviously, that's not what we want our dice to do. It's not a very useful dice if we roll it and we can't see what it does. So we're going to need to create an accessor so that we can now read this variable without exposing the ability to change that variable. We still want to be able to get the number back. So let's get an accessor in here. We'll say def get side. Okay. Now this doesn't need any extra information because it's just going to report the current value of this, and this can actually just be let's do this return self dot current side. So this is known as an accessor function or an accessor method. So this is going to tell us the value of current side. Notice what it's returning here is the value of this expression, not the variable itself. It's going to say, what is self.current side? Let's say it's 6. And then it's going to take that 6 and say return 6. So what prints out when we access it then, say def.getSide, maybe get current side is a better name. We're going to call this function. It'll jump up here, read the value of the current side, and then what's going to print out here is the number 6, or whatever number we rolled. So save, and let's try it again. There we go. I rolled a 4, I rolled a 1, I rolled a 5. But now notice we don't have the ability to change that. If I try to mutate this variable, we'll see the same sort of thing happen. If I say die underscore underscore current side equals 10, that no longer is allowed. Sure, let's change this one down to get side again. Okay, so save and try again. So it didn't crash in this case, which is a bit interesting. We'll talk about that in just a second. But when it ran through, we got, I rolled a 3, I rolled a 5. Let's run it again. I rolled a 5 and a 6. I rolled a 6 and a 3, a 6 and a 5. So we did 2 different dice rolls, and we did 2 different print statements. And in both of those print statements, we used this accessor, and we got different values because we had changed the dice. So we rolled the dice, printed it, rolled the dice, printed it again. Now this line here didn't crash our code, which is a bit strange. We might think that this is going to go into the die object, look for an attribute called current side, and set it to 10 like it did before we made our changes. But now that this is a private variable, the die object no longer has an attribute called current side. And we saw that issue when we tried to print it. So we created this accessor to get around that. But now in this case, what we're saying is create an attribute called underscore underscore current side and give it the value 10. So in addition to having the actual current side variable and the num sides attribute, then what we're also doing is creating this new attribute that's called current side and attaching it to the object. Now, this is going to seem very strange, and that's because it's very poor practice to do something like this. Generally speaking, you shouldn't just be freely attaching attributes onto the side of your object. You can kind of think of this like a sticky note that you're attaching to the side of a dice. You can put it on there, but it's only for this one specific object. It's not a great practice. And generally speaking, you should let your die class take control of all of the attributes and the behaviors that mutate those attributes. Now, the reason this isn't a conflict between current side and the self.current side here is because this underscore, as I mentioned before, does what's called name mangling. So the die object, we create a die here. The die object that comes out has two attributes. One is called num sides, and the other one we don't know what it's called. It just has some value that Python has decided. There's ways to look it up, but we won't go into that. But it's not going to be underscore underscore current side. So when we come down here and we attach this, this is actually not going to get name mangled because it's happening outside of the class. It's just going to attach this attribute to the side of our dice with the value 10. But notice when we went to get the side, it didn't say 10, it said the value of the actual attribute. So yes, I admit it's quite confusing, which is why this is bad practice. Generally speaking, don't do that. Don't try to access your attributes manually from outside your object. Create accessors and mutators to do those things for you. So let's create a mutator as well. It's entirely possible that we can pick up a dice and change it, right? We can set it to one of the sides. We can't set it to 10 on a 6-sided dice, but we can absolutely put it down to a specific value. So let's add a mutator in here as well. We'll say def set side. So that needs by default self, but we're also going to need an integer representing what side we're setting it to. So I'll say x in this case. Now this is going to be a mutator function, or a mutator method. The idea of a mutator method is that it's going to change the object itself. So rather than just exposing this variable and allowing people to do crazy things like setting it to 10 on a 6-sided dice, we're going to pass that same information into a method so that our object, or the class defining it, now controls whether or not that's an allowable operation. So for example, we're passing in which side we want to set it to. Let's first make sure that's a valid side. So if 1 is less than or equal to x, and x is less than or equal to self.num sides, that means x is an allowable value, right? It's between 1 and the number of actual sides, so then we can actually do that. So we'll say self.current side equals x. Otherwise, just don't do anything, right? Otherwise it fails. Maybe you want to have some sort of default value or error message spit out. But in this case, we'll just say, if it's not a valid operation, we're just going to ignore it. So if we want to cheat, now instead of doing this weird style cheating, we can try doing something like die.setSide and pass in the value 10. So again, this goes up to here. Self is the object that we're actually dealing with, which is die in this case, and x is going to be the value 10. Now in this case, 10 is greater than or equal to 1, which is true, but it's not less than or equal to num sides, which is going to be 6. So that's going to be false, which means this if statement is going to protect our internal private variable from being changed into something that would invalidate what would be allowed of a dice. So let's try it out. Save, and if we run our code, if our protection didn't work, we should still be able to cheat and get a 10, but if it did, we just get the regular dice rolls. There you go. Maybe we want to set it to something else though. Maybe we want to set it to a valid amount like 6. Then we can cheat. I mean, you could still pick up a dice and change it, so hey, look over there, and then change it to a 6, and now it's 6 every time. But you can't change it to something that doesn't exist. Pick it up and paint a 10 on top of it seems a bit overbearing. All right. So one last thing we can do with these dice objects, just want to point this out. It's nothing too special, but it is worth seeing once, is that we can create lists of these objects. So I'm going to add another function here, def fireball. So it's sort of a public method. It's something that's public function, something that's going to use this dice object. So we're going to make some dice first. So make dice. We're going to create a list, initially empty list, and then fill it with dice objects. So we're going to create d6s for I in range. damage, 5. Dice dot append. We've already seen d6. Actually, let's do a die 8. So an 8-sided dice. Not actually fireballs, but whatever. We're gonna have an extra powerful fireball. Right, and then we're gonna cast fireball. So again, this is from Dungeons and Dragons. If you want to cast a spell, in particular fireballs, it's just you roll a number of dice, and the sum of all those dice is your damage. So let's sum up all the damage in these dice. So we have to roll all of these. So sum equals 0. And then for I in range, len dice. I'm going to say dice at I dot roll. And then sum plus equals dice at I dot get the side. Okay. So we filled up this sum, and then we can just print it all out. Print F, your fireball did squiggly sum squiggly damage. And let's see what this does. So let's go back down to main here. Let's just, actually I'll just do this interactively. So python-i dice.py. So it runs through main, but now we can say fireball. And it runs a fireball with 30 damage. And a different one, 21 damage. There you go. So you can create all sorts of combinations. So the only thing I wanted to point out here is that objects, like any other variable, can be put inside of a list. And it just looks a little bit strange here, but not too weird. So we have this part here, dice at I, which is just accessing the element out of the list. So the highlighted blue thing here is representing a dice object, a singular die. And to that point, we can just say, take that die and run the roll method or the get side method, whatever we need to do for it. Okay, so we took an empty list, appended 5 different dice objects into that list, and then we just ran through it. Another way we could have done this, actually it's going to be all 3 of these. Oops, is that control slash? Yeah, there we go. Another way we could do this is saying for, what's a name I haven't used? Let's use D representing die, in dice. Okay, so this is just a for each loop, and now each thing in this dice list is an actual die, so we could just say d.roll, and then sum plus equals d.getSide. That's allowed as well, gives us the exact same behavior. There we go. All right, so that's the end of this video. We've seen now how to create objects. We've seen how to create objects out of classes, and how to take the attributes of those objects and prevent them from unwanted manipulation. So creating information hiding and private variables. In the next video, we'll take a look at some more fancy things we can do called magic methods.